All right, Algebra 2 guys, we're looking at 12.2, talking about permutations and combinations. So we're in this big kind of overarching idea of probability, and we're talking about permutations, combinations. We're talking about how many different ways to count things, and we're talking about how many different ways, and how does that change when order matters. That's a big, big thing here. Permutations, combinations, the main difference is, does order matter? So permutations, order matters. Combinations, order doesn't. So let's take a look. Manager of a softball team fills out team's lineup card before the game. The order in which he fills the names is important because it determines the order in which the players will bat. Suppose she has 7 possible players in mind for the top 4 spots in the lineup. Using the fundamental counting principle, how many ways can she assign players to the top 4 spots? So if you've got 4 spots, 7 choices, 6 choices, 5 choices, 4 choices. All right. So you got 7 choices for the first spot, 6 for the second, 5 for the third, 4 for the last. So that's a total of 840 different ways she can do that. Now, here's kind of what permutation actually represents. All right. You want to think about permutation as an arrangement. Okay. Permutation is an arrangement. Combination is more of a grouping. All right. So order is important. AB is different from BA, kind of when you're thinking about that. So if you look at the previous problem with the softball players, it matters if you hit first or if you hit fourth. That is a big deal. So the number of permutations, distinct objects taken, R at a time is given by P of n, choose R, n factorial over n minus R factorial, which if you'll remember from before, it just means multiply that down. So if I have 4 factorial, that means 4 times 3 times 2 times 1. So on a calculator, if I can get the calculator to work. So on a calculator can help you a lot with this. So on a calculator, if you find the PRB probability, which is either under, there it is. So if you hit math, if you look all the way over on the right, you see PRB. We're down here where it says NPR. That is what you're looking for. You've also got factorial down here at 4. But NPR and NCR are going to help you quite a bit. All right, so be aware that that's there, and I'll show you how to use that in a second. So there are 10 finalists in figure skating. How many ways can gold, silver, and bronze medals be awarded? This is arrangement. All right, this is a permutation. It matters if you get first, it matters if you get second, it matters if you get third, because you get different medals, and if you're keeping score, you get different points. So Sally winning the gold, Susie winning the silver, Judy winning the bronze is different than Judy winning the gold, Sally winning the silver, and Susie winning the bronze. So how many different ways can you award these medals? So let's take a look. So it's going to be 10, choose 3. So here's what this is going to look like. So let me quit this first. So you start off with, there's 10 skaters. Then you go to math, over to PRB, NPR, 3. That's it. Hit enter. So 720 is going to be your answer. So which, if I look, 3 should match up. So the calculator gave me 720. So think about what this actually represents. That's just 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 10 minus 3 is going to be 7 factorial. 7, why am I doing that? Don't do that. Go 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, think about this. All of these cancel out. So I'm left with 10 times 9 times 8, which is 720. All right, that's all I'm thinking about here. So the newspaper has 9 reporters available to cover 4 different stories. How many ways can the reporters be assigned to cover the stories? So here you would almost think order doesn't matter, but it kind of does, because here's why. If you're a reporter and you're covering, you get the first story that comes out, are you able to go cover the third story? No. So there's 9 different reporters. Take the shortcut over probability this time. 4 different stories, so that's going to be 3,024. So there's 3,024 different ways that 9 reporters can do this. So it's going to be 9 factorial over 9 minus 4 factorial. So it's going to be 9 minus 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 factorial. Cancels, 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 cancels. 9876 is exactly what we had up on the calculator, which was 3,024. All right, so how many different ways can the letters of the word geometry be arranged? Well, anytime you have a repetition, keep going. So all you do, the number of permutations of n objects of which p are alike and q are alike is going to be n factorial over p and q factorial. So in geometry, you've got 2 e's, and that's a repeat. Okay, so there's a total of 6, 7, 8 letters, and e is there twice. All right, so that's going to be 2. So what this ends up being is 8 factorial over 2 factorial. All right, so 8, 7, 6, 5, 4, 3. Hopefully you guys are realizing that 2 and 1 will start canceling. So I'll be left with 8, 7, 6, 5, 4, 3. That is going to be how many different ways I can rearrange geometry. Again, I'm not asking you to make words. I'm asking you how many different ways can you rearrange the letters. So that's going to be 20,160 ways. So let's look again. Here's one that's really going to mess with you. Mississippi. Mississippi's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. But there's 4 S's, 4 I's, and 2 P's. So by hand, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. The bottom, 4, 3, 2, 1, 4, 3, 2, 1, 2, 1. Again, all I'm doing is writing all this out. All right, so 4, 3, 2, 1, 4, 3, 2, 1. Those cancel out. Now I can start kind of combining some of these. So like 6 is 3 times 2. 8 is 4 times 2. So I'm left with 11, 10, 9, 7, and 5. So there's still going to be 34,650 ways to do that. So in a combination, you're not looking at an arrangement anymore. You are looking at a grouping. So you're looking at how many ways can you pick up, how many ways can you pick AB is the same as BA? How many ways can you just pick a grouping of things? Doesn't matter if you get picked first, third, fifth, or seventh, you still got picked. So notice it's a little bit different than the permutation. You got one more factorial in there where you take your number of groupings. So a permutation combination. Group of 7 students are working on a project. Choose 2 students to present their group's report. How many ways can you choose students? Well, you got to realize, if it doesn't matter if you get picked or you get first, second, you're still presenting. All right, it's not like saying the first person's got to do the first part, the second person's got to do the second part. It is, you got picked, you're going. So there's 7 students, so you got to pick 2. It's going to be this form right here. So I take 7 factorial over 7 minus 2 factorial times 2 factorial. So this is also on the calculator, if I can get there. This is also on the calculator, and it's in that same area. So if you go 7, math, PRB, look at number 3. I'm choosing 2 kids to do it. There's going to be 21 different possibilities. So that's going to kind of tell me what I do. So combinations are going to be a lot smaller than permutations. 5 cousins at a family reunion decided 3 of them will go to pick up a pizza. How many ways can they choose 3 people who will go? Does order matter? The answer is no. So it's a combination. So it's going to be 5 factorial over 5 minus 2 factorial, 2 factorial. So that's going to be 5, 4, 3, 2, 1 over 3, 2, 1 times 2 times 1. So cancel, cancel, 3 cancels. 4 over 2 is nothing more than 2. So there are 10 different ways that 5 cousins can pick 3 people to go get a pizza. So 5 cards are chosen from a standard deck of cards. How many hands consists of 3 clubs and 2 diamonds? I would say order's not going to matter here, so it's going to be a combination. So it's going to be 5 cards chosen from a standard deck of cards. How many hands consists of 3 clubs and 2 diamonds? So this is kind of actually combining 2 combinations. All right, now you're choosing 5 cards. Don't get caught up standard deck of cards. That's just there to kind of show you that it's a fair deck. 3 clubs, 2 diamonds. Well, in a deck of cards, you get 13 of each suit, okay? So 13 hearts, diamonds, clubs, and spades. I can't draw a club or a spade, so I'm just going to write it. So 3 clubs and 2 diamonds. So you've got to pick out of 13, choose 3 clubs. And 2 diamonds means out of 13, you've got to choose 2 diamonds. And like always means multiply. All right, so what's this going to be? Well, I'm going to throw this all in the calculator and let that do the work for me. So I've got 13, math, probability. 13, choose 3. Take that answer times 13. Choose 2. So total, you get 22,308 different possibilities to get 3 clubs and 2 diamonds in your hand. But do you see how it's a combination of these? 6 cards are drawn from a standard deck of cards. How many consist of 2 hearts and 4 spades? So same kind of idea. 13, choose 2 hearts times 13, choose 4 spades. So you need 6 of those. So I'm going to do the exact same thing in my calculator. So 13, choose 2, 13, choose 4. So 13, math. Oops, go to, hit that button a little too quick. 13, choose 2 times, and in parentheses, I'm just going to go 13, choose 4. So that's going to be 55,770. All right, that's all I got. Come talk to me with questions. 95% of this is in the setup. Just is it a combination or a permutation?